Hello, so in this video we're going to be talking about circles, and we're specifically going to begin by talking about the distance formula and seeing how this is actually intimately related to circles. And just so you know, this is not in your notes, not in notes. This is simply background information that's going to be useful for you to know. So just sit back, relax, and enjoy this first little bit before we dive into the notes. So the distance formula is nothing more than an extension of Pythagoras' theorem, which I'm sure you all remember, c squared equals a squared plus b squared. So in other words, if I was asked to find the distance between these 2 points, what I could do is make a right-angled triangle, just like this. And now, having made this right-angled triangle, if I wanted to solve this side, let's call this C, what I could do is first find A and then find B. Well, how would I find the length of A? Well, it simply would be the difference in my x values. So here is 1 and here is 6. So if I wanted to find what A is, it's simply going to be 6 minus 1 squared. And if I wanted to find what B is, it's going to simply be the difference in my y values. So here is 3 and 8. So it's going to be 8 minus 3 squared. And this is my distance formula. The only difference between this and this is simply that I have square rooted both sides. So I could just as easily write it as this. But what we're going to find is that when we're dealing with circles, we actually prefer it to be in this form. This means something else. We're actually going to come to that later, but let's not get ahead of ourselves. Let's now begin talking about circles. So here's a very simple question that you probably have never asked yourself, and that is, what is the definition of a circle? What is the mathematical definition of a circle? And it's simply a set of points in a plane that are a given distance from a fixed point. So that given distance is my radius, and that fixed point is my center. So when we come here to our example, here is our center of our circle, which is HK. And then what we're saying is that a circle has the same distance for any point around my circle. All of this has the distance of the radius. All of it is the radius. So in other words, if I now want to write an equation of a circle with the center at HK and the radius of R, how would I do it? Well, let me begin by writing an R here. This is my R, and we know that when we want to find the distance of something, I'm going to make a right-angled triangle, and I want to find what my R is. So all I'm going to do is find the difference in my X. So in this case, it's going to be X minus H, X minus H, and then the difference in my Y's. So it will be Y minus K. I could then write that in the Pythagorean way, which would be X minus H squared plus Y minus K squared. And that will have R squared. And this is the equation of a circle, because it will satisfy for any xy value. These are simply variables. It could be placed anywhere around this circle, and it's telling us that the distance is the same from any point around the circle to the center. And now we come to our equation, and this is just from the textbook. X minus H squared plus Y minus K squared equals R squared. And there are 2 very important pieces of information I can get out of this equation. The first is my center. The center is simply the points H and K. So as you notice, I have to change the sign in front of it, but it's very easy to identify what the center is. The next thing that's easy to identify is my radius. I simply have to square root this term in order to get my radius. Perfect. Let's now scroll down and do some examples. Here is our general formula for it without variables. And all I'm going to do now is sub in my points in order to construct an equation for this circle. So I'm going to be left with X minus my H value here will be 2. And my k value will be 4. I'm told that my radius is 3, so I'm going to square it. Don't forget to square that as well. So I'm going to be left with x minus 2 squared plus y minus 4 squared equals 9. And notice that it's very easy for me to find my center. My center is simply going to be this, change the sign, this, change the sign. And my radius is simply going to be the square root of 9, which is 3. And this is exactly what we find up here. Let's go to our next one. What you'll notice about this is that my center is the origin. How is that going to affect things? Well, we simply follow the protocol. So I'm going to be left with x minus 0 squared plus y minus 0 squared equals, my r in this case is 5. A better way to write this is simply to go x squared plus y squared equals 25. My center is going to be 0, 0, and my radius is simply going to be this value, the square root of that value, which is 5. Let's move on to our next one. And notice here that we have a negative, so that's going to affect things. But don't stress, simply follow the protocol. X minus, what's my h value here? It's 3. So I'm going to minus 3, then square it, then plus y minus, what's my k value? My k value is minus 2. So I'm going to put in minus 2, square equals, my r is 2. So I'm going to have 2 squared. I then come here and I go like this. Y minus minus 2 is plus 2 squared equals 4. To find my center, it's simply going to be this, change the sign, this, change the sign. And my radius will be the square root of 4, which is 2. And what you can see is that my center is the same as what we find here, and my radius is the same as we find there. So that's simply how we do things. Now the notes begin. So this is where everyone should now be beginning to write things. The first thing we're asked to do is find a pair of coordinates which satisfy the equation x squared plus y squared equals 25. Based on what we've just shown, we know that this is describing a circle which is the center at the origin and has a radius of 5. And there are many different points that exist along this circle. For instance, 4, 3. Let me actually change color to green. 4, 3. If I was to put 4, 3 into this equation, so let's remember my equation is this, x squared equals 25. If I was to put 4 in it, and then 3 into it, I would be left with 16 plus 9 is 25. And I could actually graph that onto my graph. It will be there, 4 and 3. I can actually have a negative number in it as well. For instance, if I had negative 4, square that, 3, square that, I'm going to be left with negative 4 squared is 16, plus 3 squared is 9, is going to equal 25. So what you can tell is that even when I have negatives, it's not going to affect things because by squaring a negative, I'm going to get a positive out. So my negative 4, 3, negative 4, and 3. So that works because it satisfies my equation and I get 25. This 2, I won't go through it, will also get me 25. So this will be 4, negative 3, 4, negative 3. And here, when I have 2 negatives, it will also satisfy the equation, 4, negative 3. Can you think of any other coordinates which will satisfy it? Perhaps an obvious one would be 3 and 4. So 3 and 4 is simply going to be the same values here. 9 and 16 is going to give me 25. And I could have 3, negative 4. I could have negative 3, 4. Or I could have them both be negative. Something else I could have, perhaps the simplest of all, could be 0 and 5. 0 and 5, if I were to put it into my equation, would be 0 squared plus 5 squared is 25. and that's going to be located here, 0 and 5. I could also have 5 and 0. I could have -5 and 0, or I could have 0 and -5. If you wanted to be a little bit tricky, you could have the coordinate 1 with the square root of 24. What's that going to give me? Well, 1 squared plus the square root of 24 squared is going to give me 1 plus 24, which is 25. And if I was to plop that on my graph, it would be somewhere here. 1 the square root of 24. So as you can see, this builds upon the idea of distance being from the center out to a dot here, as they all lie on my circle. Let's now move on and do some questions. The first one says, write down an equation of a circle with its center here and the radius that. So what we should be able to do is go x plus 2 squared plus y minus 3 squared equals 10 squared. I would then have to write that out again. Like this. So how do I know to put a plus 2 here and a -3 here? Well, I know that my signs have to change. So if I was to write out my center is going to be this but a negative, and this but a positive. And then for my radius, it's simply going to be this. It's going to be 10 squared. So my radius will be 10, the square root of that number. So these are all the intricacies that you need to learn in order to successfully execute these questions. We now come here, and I'm going to leave this one for you to do by yourself. But if I was to do it really quickly, you'd get x minus 4 squared plus y plus 1 squared equals 4. Perfect. Let's now move on to our next question. This is asking us to sketch the graph x plus 1 squared plus y minus 3 squared equals 9. The first thing I would do is I would say what my center is. My center is going to be this value but a negative, this value but a positive. My radius will be the square root of 9, which is 3. And I come to my graph and I graph it. It will be here is my center, -1 and 3. I would then go up 3 in my y direction. So 3 plus 3 is 6. That is going to be the very tippy top of my circle. So this is going to be -1 and 6. I would then get my y value and subtract 3 from it in order to find where the very bottom of it will be. And that will be -1 and 0. In order to find out how far right it goes, I would take my x value of the center and plus 3 to it. -1 plus 3 is 2. It will be here. 2, 3. And then to find how far left it goes, I take my x value and minus 3 from it. So -1 minus my radius, 3, is going to be -4, which is here. So it's going to be -4, 3. I can't yet draw it because I need to know what my x-intercepts will be. What will these be? So I would write, they're my y-intercepts. To find my y-intercepts, I'm going to let x equal 0. So I get my equation, and I'm going to put 0 into my x spot, squared plus y minus 3 squared equals 9. I'm going to get 1 here. Y minus 3 squared equals 9. I'm going to minus 1 from both sides. 8. Then going to square root both sides. I'm going to get plus or minus the square root of 8. Then I'm going to plus 3 to both sides. I'm going to get this. So that tells me that my more positive one will be this. And my more negative one, let me write it here. This should be fun to write it here. 0, 3 minus the square root of 8 is that. So notice that I have 2 y-intercepts, and that is proven correct by my drawing. The last thing I do is I sketch it. I'll warn you, I'm not very good at this, but just a quick sketch. Actually, that is horrible. Let me try that again. This is very hard. Alright, let's pretend that looks like a good circle, because it's very hard to draw it on this computer. But there you go, that's something what my circles look like. And just so you know, you really need to draw it better than this in the test. It's very important that you do that. Now, can I identify what my domain and range will be? Let's remember that my domain is all my x inputs. So you can see it starts at -4, and it goes all the way to 2. And I'm going to put square brackets because it's including these values. What does my range equal? My range is going to start at 0, and it's going to go all the way up to 6. And again, you could see that by looking at the lowest point, 0 here, and my highest point, which is 6. And again, square brackets. It's important that you develop the skill of identifying your domain and range. I know that for many of you, this is a new skill, but it's something you need to learn. It's nothing too tricky, it's just knowing where your x and y exists. Finding the y-intercepts is very important. You also should know how to find your x-intercept, all important skills. This is a question that I'm going to leave for you to do by yourself. I will put up the solution and the work solution on the OneNote, but it's important that you develop this skill independently. Let's keep on going. So now we have to learn that there are 2 different forms of a circle equation. We've been dealing with this form. And this form is nice because it's immediately clear what my center is and what my radius is. But we also have the general form. And the way that these two are related is simply that I've expanded these brackets. So to go from this to this, I'm just expanding. Now, in most cases, we want our equation to look like this. So we need a way to get from the general form into this form. And the way that we do that is by completing the square. Because as you see here, we have 2 perfect squares. So by completing the square, we can go back to here. And of course, we want to go back to here because we have that center being very clear and the radius being clear. So let's now do an example of this. So it's asking me to sketch this. It's in the general form, but we don't like it in that form. So let's zoom in here and do some maths. So the first thing we're going to do is I'm going to group together my x's, and then I'm going to group together my y's. So my x's will be x squared minus 6x. Then I'm going to get my y's. It's going to be plus y squared plus 4y. And then it's going to be equal to 12. Let me scroll down. And now I'm going to complete the squares. This was on a skill sheet, and it's very important that you have the ability to go x squared minus 6x. Now I'm going to take the coefficient of this term and half it, which will be 3, and then square it. Then I'm going to minus that, and then move on to my y's. So now I'm going to have y squared plus 4y. Again, I'm going to take the coefficient of this term, which is 4, and halve it. That is 2. Then square it. And then I'm going to minus it. And I have my 12 here. Let's not forget about that. I now can make a perfect square out of this. That is going to give me x minus 3 squared. And I have my minus 3 squared here, which is going to be minus 9. I then can make another perfect square here. This is going to be y plus 2 squared. And of course, I have my minus 2 squared, which is going to be minus 4. And then equals to 12. And now I'm going to write it in black and finish it off. So I'm going to have x minus 3 squared plus y plus 2 squared equals 12. And I'm going to take this minus 9 and this minus 4 over to my other side. They're going to become a plus and a 4. X minus 3 squared plus y plus 2 squared equals 12 plus 9 is 21 plus 4 is 25. And that is our very last equation. So we have successfully transformed my general equation into a more friendly form for when we graph. So let me zoom right out of here. Oops. So I have x minus 3 squared plus y plus 2 squared equals 25. With this, I can immediately see what my center is. My center is going to be plus 3 minus 2. 3 minus 2. I also can tell what my radius will be. My radius will be the square root of 25, which is 5. I now have to graph this, so I'm going to find 3, and negative 2 is here. I then am going to go up 5. Let me actually write this in. 3 minus 2. I'm going to go up 5 from my y to find where my graph goes up to the very top. So negative 2 plus 5 is 3. So this will be 3, 3. I then need to find how far lower it goes. So I'm going to take minus 2 and minus 5. So it's going to be 3, negative 7. 3, negative 7. I then am going to find how far right it's going to be. So this time I'm going to get my x and plus 5. It's going to go to 8. So 8, negative 2. And then I'm going to take my 3 and minus 5 and come to negative 2. Negative 2, negative 2. I now need to find both my x-intercepts and my y-intercepts. I'm going to scroll down a bit. Actually, no, I should be able to do it here. Let me grab a colored, let me go with blue. So I need to find my x-intercepts. So I would write 2, let me go a bit smaller, find x int, let y equal 0. Let me zoom in here, just to make it a bit easier on ourselves. So I'm going to let y equals 0 to find x. So I'm going to be left with x minus 3 squared plus 0 plus 2 squared equals 25. I'm going to be left on this side the same. This will be 4, 25. I'm going to minus 4 from both sides to get 21. Then I'm going to square root both sides. This will be plus or minus. And then, oops, I can get rid of that. I'm going to be left with x equals 3 plus or minus the square root of 21. And that is what I'm going to get for my x. I then need to figure out what my y will be. Let me come up a bit and say to find y int let x equal 0. So it's going to be 0 minus 3 squared plus y plus 2 squared equals 25. This will be 9 plus y plus 2 squared equals 25. I will minus 9 from both sides, and this will be 16. I will then square root both sides to get plus or minus 4. I will then minus 2 from both sides to get minus 2 plus or minus 4. That means I'm going to get y equals minus 2 minus 4 and y equals minus 2 plus 4. That means I'm going to get 0, negative 6, and 0, 2. And over here, this will be 3 plus the square root of 21, 0, and 3 minus the square root of 21, 0. So I have 2 x-intercepts and 2 y-intercepts. Then we zoom out, right out, come up here, perfect. Let me get my blue and mark in my y-intercepts. So it's going to be somewhere here, and of course you would write in your more positive one, so it will be 3 plus the square root of 21, 0, and then go over to your other side, which will be about here, and this one will be your negative 3 minus the square root of 21, 0. Then I will put in my y-intercepts. One will be here, 0 minus 6, and the other one will be up here, 2, 0. I can then graph it, and again, you know I'm not very good at this, but let's just pretend this looks good. Oh, that's actually pretty bad. Let me try again, because that should just go right through it. That's pretty bad. Then it should go like this. And again, it's very important that in a test, you would draw this better than how I'm drawing it now. There we go. Perfect. So that's what it's going to look like, basically. And if you were to find your domain, what would it be? It would be from -2 to 8. And your range would be from -7, all the way up to 3. And what mistake have I made there? Simple mistake of putting a circle bracket. What am I doing? There we go. So that was quite an intensive question there, but we got through it. Let me just zoom in to get this right. Oh no, something has happened here. Can I get rid of this? Oh, okay. It's just going to follow us down. This one is going to be up to you to do. I will leave the notes on the OneNote for you to check your answer. Let's now talk about circles and inequalities. I really wish this would go away, but it's not going to, so let's just live with it. I have x squared plus y squared is less than 5. The way to graphically represent this is by shading in the inside of my circle. And this makes sense when we start subbing in coordinates which satisfy this inequality. For instance, 1 squared plus 1 squared equals 2, and 2 is less than 5. If I now come here and put in 1, 1, you can see that it lies within the shaded region. If I was then to do the same thing, sub in this coordinate into this inequality, I'm going to get 2 squared plus -3 squared, which is going to be 4 plus 9. 4 plus 9 is 13. Now, is 13 less than 5? It is not. Therefore, this does not work. If we were to plot this on our graph, we would get 2, -3, and as you can see, it doesn't work. This one does work, this one doesn't work. Let's now go to our final example of 1, 2. If I was to sub this coordinate into this equation, I'm going to get 1 squared plus 2 squared, which is 1 plus 4, which equals 5. Now, is 5 less than 5? The answer is no, it is not. If it was 5 less than or equal to 5, it would work, but this won't. And this again makes more sense when we look at it graphically. As you can see, it exists on the dotted line, and the dotted line means it actually isn't a part of our shaded region. And that makes sense when we see it mathematically. When we now apply the same logic here, when we put 1, 1 into this, we're going to be greeted with 2 is greater than or equal to 5, which of course is not true. So this doesn't work this time around. And that's because we're now shading in the region outside the circle. And notice now we have a greater than or equal to sign. So we have a solid line. But 1, 1 lies here. And as you can see, that's not within the shaded region, so it doesn't work. We could then come to our next equation, which we know is going to equal 13. Is 13 greater than or equal to 5? It absolutely is, so this works. And we could graph this here. It's going to be 2, -3, and as you can see, is in the shaded region, so it works. The last one we have is 1 and 2. 1 and 2 exists on the line, on the solid line. We know that we're going to get an outcome of 5 is greater than or equal to 5, and we know that works because it's the equal to sign. So this will work. Whoops, that wasn't green. This will work. These are circled and inequalities. This is important that you know. Let's move on to the next one. Oh, and my computer has decided to break down on me. So let's actually leave this video here and I'll continue it in a new one.